Hey everyone, so this is question number 10 from section 11.2, and we have a question in the beginning is about interaction. All right, so between the filling time and the mold temperature. All right, so first of all, that's a suggestion. Before running the data and doing everything, I mean, I'm supposed to know the interaction, there is interaction not once I run the data. So I'm supposed to download the data from here, go open it in Excel and open it this way. So there is an issue here that while you are running the data, it might take some time and the exercise might assume that you are not active, so it's going to kick you out. So in order to avoid this, you need to start with the first question. So let's answer to the first question, which is not really difficult. So the first question is asking about the interaction. All right. And this is statement from your book. So it's always the same. So the hypothesis for the interaction between A and B is always H0. The interaction is equal to 0. And H1 will be the negation of that the interaction is not equal to 0 or different than 0. So let's go ahead and look for the correct statement. So what we got here, we are looking for is equal to 0 as in first statement. So this is equal to 0 is good. This is equal to 0 is good. This is not, and this is equal to 0 is good. All right, so it could be is not C, we know, right? So here is saying greater, so this definitely not. Here is saying less, definitely not. This is saying not equals, which is good. So most likely is D. All right, so let's go check D and check it. We got it. So we assume right now that the question will wait for you until you run your Excel. So you can go back to your Excel. All right. So now we want to run this data. So the issue with the data is not properly set up for our data analysis test. So what I'm going to do, I'm going to have to rearrange it. First of all, I'm going to copy these two, put it in here, and then I'm going to move the mold temperatures, right? So for the first one, well, let me drag it. I need 3 of them here. So there are 3 mold temperature. For this one, I'm gonna write down the filling time is gonna be 1, and then I'm gonna drag it. Let me put space here. All right, so once I get this, I'm gonna drag it. This should give me 1, 2, 3. All right, so let me put some space. Great. Now for the molding temperature, the first one is going to be at 60, and you can see it here. So I'm going to go to this one and change it to 60. The second one, you can see it is 72 right here, so 72.5. And the third one, as you see it here, is 80, whatever remaining. So I'm going to go and type in 80 there. All right, great. Now for the filling time, there is 1 here, 1 second, right? So do you see a replication of 3 and then 2, 3, and then for 3 seconds 3 as well. So what does this mean? It means that I need to space them with 3 in each one. So that's the first one, 3, and this is the third, and I need only 1. This is the third one. Okay. So do you see the numbers right now? This is the independent variable. So the first one corresponds to 1 and 60. 1 and 60, I can drag it and put it here. And so forth. So this is for 2 and 60. I'm going to drag it. You can drag it whenever you see the cross with arrow. So that's you're going to move it here and so forth. And here you can drag it, or you can copy and paste or cut and paste whatever it's easier for you. Okay, so we finish, we get our data done. So I'm gonna go right now to data analysis under data table, and then I'm gonna look for data analysis, and I'm gonna look for two-way ANOVA with replication. Say okay, and then select the data. So the data, you select everything including the labels. All right, and the row per sample, that's mean 3, that's replication of 3, and the output range, and you just select somewhere, all right, where you want your data out. Okay, we're done. So we get this already, the table, and we want to look into this table for now. All right, so let me put it in different color. Okay, now let's go back to the question, and as you notice here, the question still waiting for us is asking for the F statistics for the interaction. Or if I'm looking for the interaction, F statistic would be this. Thus you can see interaction, and the F value is right here, so I just can copy it, go back and paste it. And here they want 2 decimal places, so you can round it properly, you can delete all the number. Is 2.26, and that's all. Check. Okay, now they're looking for the p-value, and the p-value is next to it, and I'm gonna copy, then paste it again. And they want 3 decimal places, so you're gonna be 0.1026, that's 1.03, and check. Good. All right, so now it's asking you whether you're gonna accept or reject, and the answer is always almost the same. It's depending on the p-value and the alpha. So this is the alpha, which is 0.05, the p-value is 0.1. Greater than the alpha, we do not reject. And if we did not reject, this means we don't have evidence, or we don't have sufficient evidence. So we have insufficient evidence to make a conclusion. And let's check it, and we're good. All right, so before moving on to the following question, we notice here that the F's, so all the F's, they want 2 decimal places, so I can select all the F's, and I'm gonna go to format cells, and you want numbers, and you want 2 decimal places, so make sure this is 2 over here, and say okay. You're gonna round it for you. Select all the p-values, right click, go to format cell, and here you want to go to numbers, and you want to make it 3 decimals, and okay, and that's gonna be rounded as well. Okay, all right, so for question B here, we are doing basically almost the same thing what we did with the interaction, but we are focusing right now on one of the effects, either A or B. So the effect that we are focusing on is the filling time. All right, filling time 1, 2, and 3. So this is from your book. This is our standard, all right, for two-ways ANOVA. So here for 80, it's going to be hours, the means are equal to each other. And for H1, not all the means are equal, or at least one of them, at least one of the means is different, right? Okay, so we are looking for equivalent statement to this. All right, so the first one should be are all equals. So this is there is no effect. Whenever there is no effect, it means the means are equal, right? So no effect due to filling. There is no effect due to filling time. So that's A. That's it could be C, and as well it could be there is no effect as well for D. So B is not. All right, and then there is an effect which is the opposite to to this one. So an effect, it means one of them is different. So here there is an effect, which is what we are looking for. If I look for the other one, here they are saying, you know, positive effect and negative effect. We don't really study this. We don't study this effect, whether positive or negative, in two-way ANOVA, right? So just there is an effect or there is no effect. That's always the statement you are looking for. Therefore, the correct answer will be the A. All right, we can check it. We got it correct. Now they are looking for the F value. So the F value I need, for the F value I need the Excel, going back to Excel. So right now we are talking about the filling times. The filling times, you can see it here, is on the columns, all right? Column 1, column 2, column 3. So you're gonna go to your table again, and you're gonna select this row. So this is what you wanna look to, all right? And this is the column. So the column, the F value is right here. We can copy it. We can go back to the question and we paste it in. So 8.97. We got it good. For the p-value, that's the number next to it. That's p-value there. Copy it again and paste it, and we check it. And that's good as well. All right, right now the conclusion again. So the conclusion, one more time, probably you wanna memorize this. So every time the p-value is small, you are rejecting the null hypothesis. If you reject the null hypothesis, it means there is an effect. All right, so the p-value is smaller than 0.05. This is less, so we are rejecting the A0. So the A0 saying no effect, we are rejecting it. And every time you reject A0, there is evidence, or there is sufficient evidence. All right, and done. So now we have a similar question. We are dealing with the second effect, and this effect is the molding temperature. And we can go to our table again. We can see the molding temperature is right here. They are in a row fashion way. So the rows are referred here by sample, and this is the column that you are supposed to look into, right? Okay, and let's go back. So the null hypothesis will be there is no effect, and the H1 would be there is an effect. All right, so here there is no effect, which is good. There is no effect. This could be yes. This is there is no effect. It could be yes, and this one could be no. There is an effect is saying, right? Okay, so we know the first three. So one of them is going to be positive effect, don't select it. The other one you're going to say negative effect, don't select it. You're going to select B, the one that's saying no effect, and the alternative, there is an effect. And check it, and we're done with this. So the F value right now, the F value is 424, so we can type it in. 4.24. Okay, and the p-value is right here, so let's copy it. Is 0.031. Okay, check. We good? All right, so now we're gonna do again a conclusion about this. We compare only the p-value that we just found here with the alpha value right here, so 0.005 and 0.003. So this is basically, if you add the 0, you're going to be 50 and 31, so the p-value is smaller. So p-value is less. If it is less, you reject, and if you reject, you have evidence, you have sufficient evidence. Okay, we are all set. Now they are trying to figure out which one of this chart is the one that you're going to consider. So probably the best way to figure out this, open one of the chart and you see here what they have in the bottom. So the filling time is on the bottom and the temperature is going to be on the Y's, right? So let's see how can we construct this graph. So the filling time is the axis, so this is going to be your axis. And what you're going to graph right now, you're going to graph these averages. So let's put them in yellow. So this average here, this average here, and this is the third average. All right, so it's really simple. So what you're gonna do, you're gonna go to insert, you're gonna go to this chart here, and you insert the first one. So it's an empty chart, don't select any data. And then you're gonna right click and you're gonna select the data here. So once you open this dialog box, you're gonna add one of the series and you're gonna ask you what the name of the series. So the first one, we are graphing the mode of temperature 60. So I'm gonna select the name there, and here I'm gonna erase this part and select the values, and the values are right here, the averages. All right, and you're done with the first one. And then I'm gonna add another one, and I'm gonna select again the name. So the name is gonna be mold temperature 72.5, and here I'm gonna select the values. I'm gonna select this row of the averages, and I'm done with the second one. I'm gonna add another one. So here the name is gonna be mold temperature is 80, and for this I'm gonna select these three values, and I'm pretty much done. So now if you notice here, this is a chart, there is 1, 2, 3 here. So I don't want 1, 2, 3, I want temperatures. So I'm gonna go and edit the axis. This is the axis of the axis, and I can select this and then the filling times, right? And there you go. So this is good. So now probably you are confused which and which. So you can click on this one, you can add a legend. All right, and this is your graph with the legend. If you want to know what you are graphing, probably you can add the data table on the bottom if you want to. All right, you can play around with this, right? So this should be enough. All right, so let's select this, make it bigger. All right, this is the graph that we are looking for, right? Okay, so let's go for the multiple choices and see which one. So basically the blue line is on top too. They are not intersecting, only in the beginning, all right? And if I look carefully, I think this is the correct one. Let's open it. Yeah, this looks pretty much the same. So that's B. All right, let's check it. Great. Okay, so here is asking whether you're gonna use the Tukey multiple comparison or not. All right, so there is a condition here whether you apply it or not. So let me explain it in a moment. Okay, for the multiple comparison, all right, the Tukey process, there is a condition, in fact. All right, so the condition here is if one or both of the factors are significant, all right? And the second one, there is no significant interaction between effect, all right? And if I go back to my questions, you see for the interactions, we say there is no interaction, right? So we did not reject A0. It means interaction equals to 0, means no interaction. Thus the interaction part is checked. And for the effect A, all right, for the effect A, we rejected A0. That means there is an effect due to certain of the factors. So in this case is the filling time. And for the other effect, we rejected A0 as well. So there is a significant effect, at least for one, and this is the second one, all right? So yes, we can conclude that we need to do the comparison process. And we're gonna try to do it on Excel in order to figure out how to get these choices. Okay, so in this question A, we are gonna do the comparison procedure, all right? And for this question, we are doing the filling times, right? All right, so here determine which one of the filling times differs, all right? So we are focusing on the difference of the filling times. So here, I already create some tables. So the table I'm gonna follow, basically this is from your book, and I need to compare the different groups, right? So let's start with this process together. Now define my groups. So group 1 is gonna be filling time 1. Group 2 is gonna be filling time 2, and so forth, 3. Now I need to fill up this data. So I need to figure out how many rows do you have here, how many columns. So the number of columns, you remember this is our table, right? We have 3 columns and 3 rows, by the way, only 1, 2, and 3, right? So the R and the C are gonna be 3 and 3. Here they are not degree of freedom, right? So don't mix it up. N prime is the replication, all right? So how many times does the data replicate? Here you can see it is 3 times, all right? And that's going to be N prime. Now, although this is a formula, R times C times N prime minus 1, which is 3 times 2, and that's going to be 18. However, you can find it right here. So that's the within degree of freedom, all right? So this is going to be just 18. The MSE, the mean square error, again, that's going to be MS and within, all right? So this is the within is the error, all right? So this is the value of MSE. So I'm gonna just put equal sign in it, equals, and then select it, enter. All right, the QC and QR are gonna be formulas. We're gonna do it together. Here, the comparison about the groups, all right? So what are the groups? We have 3 groups, and the formula is saying that n times n minus 1 divided by 2, and that will result. So the formula number of groups is n times n minus 1 divided by 2, and that's going to be 3 times 3 minus 1 divided by 2, and that's going to give you 3 comparison, all right? Okay, so this one is going to be group 1 and group 2. It's going to be group 1 and group 3, and group 2 here with group 3. So that's all the combinations, all right? And then I'm going to calculate their absolute value, difference of their absolute value. So this is going to be a formula, equal sign, and then I'm going to make a difference of the absolute values. Before going there, let me define what I'm going to do first. The value that I'm going to be using is the filling times, and what you're going to do is you're going to go all the way to the totals, and this is, you can select the averages. So this is the number that you're going to be using for your differences. So this is the average 1 for group 1, this is the average 2 for group 2, and this is the average 3 for group 3. Okay, so going back, I'm gonna do equal sign here, equals absolute, that's absolute value in Excel, open the parentheses, and you're gonna select the first group, which is the first one, minus the second one, that's the second group, enter, and that's the value. And for the second one, I'm going to do exactly the same thing, absolute value. So now the first group is still this one minus the third group, which is this one. Enter. And for the last one, you're going to be equals absolute value again. Open the parentheses. You're going to be between the second and the third. This is the second minus the third, and this is enter. All right, we get these values already. So this is the difference. Now we're going to compare the difference with the critical range. So let's get into the calculation of the critical range. All right, so as I mentioned earlier, so we are doing the procedure for factor B, that's the columns, all right? And factor B, this is the columns. So we're going to look for the Q alpha, all right? We're going to need degree of freedom, and we're going to have to plug it into this equation to find the critical range. All right, so before starting the formula, I need to define what is my C and this value, which is RC n prime minus 1. So you notice here the C, that's the number of columns. This is one of them. The R times C times n prime minus 1, that's going to be this one, 18. So now I'm going to use the table, and the table is provided for you in this question. So you have to go to this one, open it, and then you need to, I'm going to copy it to Excel. So copy to clipboard, and then I'm going to copy this one, and I'm going to have it on my spreadsheet here. So let me put it right here. So this is my table. So what I'm going to do, I'm going to follow the C and the 3 and the 18. So the C being the numerator or the horizontal value. So I'm going to select this one up to 18. Okay. And then with 18, cross it with 18 here. And the value that I'm looking for is the cross one, right? So this is going to be the value, 3.61. So then I'm gonna, the QC here for, well, because I'm doing columns, I'm gonna use this one QC, and I'm gonna equal sign and put it, select this value. Or type it in, it's easier. Okay, once I select the QC, I'm gonna follow this formula right now. Now the critical range, okay, so this is gonna be equal sign, so I'm gonna select the QC value and then multiply it, square root SQ RT, open the parentheses, and MSE right now is this value over here. Click on that one and then divided by, open the parentheses, R times n prime. So the R is being 3 times n prime is 3, and close the parentheses twice and enter. So this is 0.26697. So this is my critical value that I'm gonna have to compare with it, right? Okay, so I don't need this formula for now. So where the critical value, you're gonna go right here. So this is equal sign, and I'm gonna select this value, and I'm gonna lock it with function F4. Otherwise, put a dollar sign before the letter and the numbers, and that's gonna be that the value. The reason why I lock it because I'm gonna drag it, and I needed the same one here. Okay, now I'm gonna make my conclusion. So the conclusion will be depending on these two values. So if the difference is greater than the range, critical range, you are saying the groups are different. If the absolute value of difference is smaller than the critical range, you're gonna end up with the result the two groups are not different. So I'm gonna use if function here, equal sign if, open a parenthesis, if the difference is greater than the critical range, I'm gonna say between, all right, so I'm gonna say here, all right, so what you're gonna say here, the groups, if it is greater, groups are different. Now, otherwise, you're gonna put a comma, you're gonna put it between quotation, the groups are not different, and close the quotation and enter. So this is gonna generate a statement directly from Excel, and there you go. So the difference between groups is only between group 1 and 3 and 2 and 3. All right, so that's the conclusion. Now I know it's a lot of work, but hopefully we get this one correct. Let's go back to the question. Okay, so what we said, there is a difference between 2 and 3 and 1 and 3. So this is 2 and 3, this is 1 and 3. Between 1 and 2, I don't think there is any difference. So 1 and 2, as a matter of fact, here there is no difference, are not different. And that's basically it. Let's check the answer. We got it. All right, so that's the way to do it. Here is asking you to do exactly the same thing, but by using the rows instead of columns. So let's try to do it. We have almost all the job is done. So we can have to calculate the, first of all, the QR here. So degree of freedom. Let me get the formula first. Right. So here is the formula for the factor A. And what is different here, you can notice the degree of freedom could change. So for this one, you have a degree of freedom is R, and this R times C times n prime minus 1. So you see is different from C, what we used before, right? So these 2 degree of freedom are this one, the R. So let's change the color. And this is the other degree of freedom. So 3 and 18. And it is the same value. If you do 3 and 18, you're going to end up with 3.61. So this value is the same thing. You can type it in, don't drag it, 3.61, enter. So we got that value. Now we can plug it into the formula. So we're going to change here from factor B to factor A, and the formula is equals, I'm going to select the Q for the rows, which is that one. I'm going to multiply it by square root SQRT, open parentheses, and then I'm going to select MSE, so this is the value of MSE, and then divide it, open a parentheses, C times n prime. So C is 3 times n prime is, oh, C is 3, actually here, that's C, and times n prime, that's the value, and close the parentheses twice, enter. And this is the value of the critical range. Now I'm gonna create a different table very similar to this. Let's get rid of the formulas. So I'm gonna copy this one, it's easier for me, and then paste it over here. So what you're gonna change, so I don't need these values here, and for this one I'm gonna change it for factor A, and factor A is the temperatures, right? Okay, so now I need to define my groups. let's go to the groups here, and group 1, you're going to be, the first group is, can go to the table, molding temperature 60. Second group, you're going to put equal sign instead of typing it and select the second one. And the third one, you're going to be equal sign again, and you're going to be temperature 80. So we define our 3 groups. Now we know group 1 and group 2, what does mean. And let's put this in a fashion of table. Okay, so we're going to do the difference of absolute values. So let's define the values, right? So now, do you remember for the columns we use these values here? However, for the rows, we're going to use, if you extend the averages, you see the totals, right? So that's the totals of the average. So this is 1. I'm going to select control second one, control select the third one. They are the 3 of them, right? I'm going to put them in a different color. All right, so they are the 3 values that I'm going to be using. All right, and what you're going to do, you could even select these values and just let's select them. Select the first one, control, select second one, control, hold the control key and select the 3 of all of them, control copy or copy them. All right, and then what you're going to do, you can put them right here. So those are the values, right? Like that, we don't have to travel far away. Okay, so, oh, actually not there. Let's put them here, right here. Okay, so we have the 3 values. We're going to do the difference. You're going to be equal sign. So absolute value, open a parenthesis, you select the first minus the second, close the parenthesis and enter. Next one, you're going to be equal sign, absolute value, open a parenthesis, the first minus the last one, and close the parenthesis and enter. And the last one, you're going to be absolute value, open a parenthesis, and you're going to be the second minus the third, and enter. So we get the difference of absolute value. This is a critical value here. You're going to be equals, and this is my critical value. Please lock it, function and F4, or put a $sign before the letter and before the number, and drag it later on. So choose it and drag it down. Now for this one, for the result, instead of typing it again, I can go and copy this one because it's same function, same statement. So copy, control V, and that's going to give me the statement. And then I'm going to drag it down here as well. So the only group that having a difference is between 1 and 3. All right, the other 2 is fine. So 1 and 3 is the only statement that is different. Okay, going back. So what is group 1 and what is group 3? Group 1 is temperature 60, 3 is 80. Only 1 and 60 and 80 is different. So 60 and 85. Okay, I made a typo there. I say 80, but anyway, you got it, right? So 60 and 85, and let's check it. We got it. Okay, the next question here, we want to figure out whether this statement. So at the level of 0.05 level of significance, there is, here is the effect of filling time, right? The filling time, it was a statement that we did already the test before, and we say there is in the beginning no interaction, no for the interaction, but there is an effect for the filling time over here. No, not that one. Yeah, right here, the filling time. All right, there is an effect, and we have as well, there is an effect for the conclusion, sufficient evidence we rejected. There is an effect for a temperature, right? So for our statement, Here there is sufficient, all right, there is a significant effect due to filling time, and there is a significant due to temperature. Now the greatest warpage, this we can use the chart, all right. So the greatest here is basically in the greatest height point here is under filling time 3 basically, right? And that's happening for temperature 60 and temperature 72. The 80 is not moving, it doesn't change. So the greatest is going to be in filling time 3. So let's go, let's see the choices. All right, filling time 3 is basically 3 seconds, all right? So the greatest happen at 3 seconds, and the interaction between filling time and modes is not significant because we say there is no interaction, all right? Hopefully this is correct. We got it.